Welcome to our Consumer Lab report.
I'm Kristen.
I'm Molly.
And I'm Brian.
And our purpose and question in our experiment was, does the color of light affect how much energy a solar cell collects?
Our hypothesis was if color affects the amount of energy that a solar cell receives, then no color will give the most energy because nothing would be blocking or filtering the light.
Our independent variable was the color of light, our dependent variable was the voltage, and our control was the no color filter.
Our materials were solar cell, the light, the different colored plastics which change the color of the light, the voltage meter, and all the positive and negative cords that connected the voltage meter to the solar cell, and writing utensils and paper.
Our background info was the solar cell is a device that converts the energy of sunlight directly into electricity, and Da Vinci predicted a solar industrialization as far back as 1447.
Also, solar energy is very useful to those who have access to it. It can produce lighting for indoors and outdoors, as well as to heat swimming pools, power cars, for attic fans, calculators, and other small appliances.
Our procedure was to obtain all necessary parts, place a solar panel under the light, turn on the voltage meter to the 2 decimal point, then turn on the light to let the solar panels sit for 2 minutes to warm up before conducting the experiment, and then place the color, and then attach the cords to the positive to negative and negative to positive, and then place the colored filters underneath the light.
And then that affects the numbers on the voltage meter.
So this is the data we got. From all this experimenting, and we have the colors of the lights, and then our trials, and then the average millivolts collected. For blue it was 72.6, for purple it was 75, for orange it was 74, for yellow it was 73, and green it was 72.3, and with no color it was 76.3.
And then this is our graph. And the highest average we got on our graph was the no color, which was 76.3.
As you can see, they're all around the same voltage, but the no color still. Our hypothesis was that if the color of light affects the amount of energy that a solar cell receives, then no color will receive more energy because nothing will be blocking or filtering the light that the lamp gives off. We were right because having no color light had the highest average millivolts received.
We know that having no color filter will let in the most light because while all the other colors let in an average of 73 to 75 millivolts, the no color let in over 75 millivolts when tested using our experiment.
Some possible errors that could have happened are that the light got warmer and warmer the longer we tested. This made the light stronger, therefore giving the solar cell more energy. Another error that could have occurred is that we used a different solar panel each day, and even though they appeared to be the same model and size, we could not fully ensure that they all had the same capabilities. Both of these errors could have affected our results.
Ways we could have improved the experiment include letting the solar cell heat up before we measured the millivolts that the cell absorbed, because the cell heated up as we went along. Because the cell and light got warmer, it could have made our results inaccurate. We also could have made sure that we used the same color filter every time. We had a big stack of different colored plastics, and it's possible that we used ones of different thickness and shades because the experimental process took place between 2 different days. That is how we could improve our experiment.
And now Travis and Brian are just going to show you how the solar cell collects all this energy.
Alright, so we're connecting, instead of the voltage meter, we're connecting it to a little motor. which, when exposed to the light, spins. The closer you get, the faster it goes.
And then if
Or the light is slower. When you turn it off,
the motor will completely stop, and then when you turn it on again, it'll start. Okay. Bye.
Okay.
uh,
The end.